Welcome back to Rod's Radios. This is part 2 of the Grundig Satellit 2400 repair and restoration. When we left some weeks ago at the end of part 1, I was waiting for parts to come in to restore the output stage and the distortion in one of the channels, and also the button covers that my daughter was making for me. So in the meantime, I turn my attention to the dial drive. If you remember in part 1 when I was looking at this, the dial drive was extremely stiff when you were turning either the coarse tuning on the outside of this shaft or even the fine tuning one, and the dial itself tended to slip along the front here as you turned this. So there was slipping and it was extremely tight. So the first thing I decided to do was to actually change the tension to try and stop the slipping of the cord, which goes all the way around the top of the radio and back around here to the pulley. And on its way there is a tensioner here supported by a spring which pushes this little pulley outwards to tighten the tension on the cord. So I put a stronger spring in at this point here, and right enough the dial itself stopped slipping. So I wasn't particularly happy about that because it really wasn't solving the problem, because the dial itself was still fairly stiff even though it was moving smoothly, but it took quite a lot of force to move it along the dial itself. So I took off this white plastic pulley here that is connected to the tuning capacitor, and I oiled both the capacitor itself at the point behind here where the shaft goes into the capacitor, and also the back bearing on the capacitor and the intermediate bearing as it goes through the capacitor. I also oiled the vernier drive itself at this point in here where there's a ball race, and I discovered that actually the ball race, which sits in a greasy goo, was actually gone quite hard, and this was actually contributing mainly to the force required to turn it. So having oiled all these parts, it suddenly got an awful lot easier to turn, and I think it's quite normal now. So I put back its normal spring that sat here originally, and it still continued to move absolutely perfectly. So that's sorted. Thank goodness for that. I'm ready to start working on the control panel in replacing the transistors and the chip, which I need to access by removing this panel because the chip is located on the main board. And to do that, I've released all the plugs and sockets coming from this panel, and also some of the wires. Some of the wires go over to the battery meter, some of the wires go to the digital readout, and there's a couple of more wires here that disappear into the black hole at the back here. Now it's important to write down all these removals as you go along, because if there's an interval between the time I remove this and get round to repairing it, I might forget what goes where. So I've written down all the bits and pieces, where they go, and hopefully that will keep me on the right track. Finally, the control panel is released from the main chassis by the 4 black plastic clips here and here, and I can now start working on it and replacing the 2 suspect transistors and whatever might else be faulty around that area. They're located around this point here. It's also helpful, by the way, to take plenty of pictures with the phone to remind myself what goes where when it does need to be replaced back. In order to replace the audio output chip, I started to disassemble the whole chassis, taking off the control panel. And around the back here you can see I've taken a lot of the bits off the main part of the chassis. However, I have got stuck at this point in that I can't get the main PCB board out. It'll come out at this side, but it's stuck over here because it's attached to this board here, which in turn has 2 shafts going out the front. And because the chassis needs to be tilted out in this direction and out in that direction because of the fact it's held captive by two clips at the bottom here. I just can't figure out how to get this panel out. There are two shafts running through to the front which won't allow that happen. Now, in the meantime, I discovered that to get access to the output chip, which lives down here in the bottom corner, there is actually access through the side of the chassis here at the base, at this point here, which means I can unscrew the screw that holds the heatsink onto the back of the chip. And I've done that at this point and spent about maybe a half an hour trying to extract the chip, which proved extremely difficult. It has 9 pins soldered along this point here, and it took a long time to get the chip out. In actual fact, I had to bend the chip back and forwards until the legs broke off, take out the chip, and then round the back here, desolder all the little stubs of wire that were left coming out through the PCB board. You can see here side by side the old chip and the new chip which arrived in the post the other day, TDA 1037. They're both Siemens chips, and this one happens to be dated. The original chip is dated week 40 of 1980, and the new one is dated week 30 of 1991. So I'm swapping a 40-year-old chip for a 30-year-old chip. I hope it works. The button covers for the missing parts over here finally arrived from Australia 8 weeks after having been posted. And I'm very happy with the outcome. These were printed on a metal 3D printer, and they're a pretty good substitution for one of the original button covers that you can see here. So I'm going to tidy them up. I may even spray paint them just to even out the surface, and glue them onto the existing shafts, or what remains of the shafts over here, one by one, to get them to line up hopefully pretty perfectly. So we'll see how that one works out. So these are going to sit on here like that and glued in place. And here's the buttons ready for spraying. I had several different cans of silver paint, so I picked the nearest one to match the original buttons, and I've glued them temporarily onto this piece of board to stop them blowing away as I spray them. So hopefully they'll turn out well. Let's see. And here's the result, as you can see, and I've put one of the original buttons over on the right hand side just to show the comparison between the original and the 4 new buttons. So back to fault finding now, and having replaced the output chip here, the TDA 1037, I was sure the set was going to burst into life. And guess what? Nothing, absolutely nothing from this channel still. I couldn't believe it. Did I make a mistake in taking out the old chip and fitting the new one? Anyway, back to the drawing board, in this case the circuit diagram, and this is the output stage. And again, I used the scope to look for a signal on the loudspeaker. Nothing. Back through the socket here, the extension socket, nothing. Back through this point here, nothing, all the way back to this, still nothing. And just by chance, I went onto pin 2 of the chip, and the signal sprang into life. So hang on, this didn't make sense. I was getting no signal here, and I was getting a signal here. So I went further along here. I still had a signal on this side of the capacitor. Don't tell me the capacitor was open here. So I tried on the other side of the capacitor. Yeah, I still had a signal. I couldn't believe it. This didn't make sense. So I went back to this point here. Could it have been this connector here? No. I tried on both sides. So I had no signal here, and yet I had a signal here. And it turned out that there was actually a break on the print somewhere on the main chassis from the positive side of this capacitor to where it went to this connector. And indeed, when I bridged the 2 points, and it was pretty difficult to get at these because this is on the chassis that I wasn't able to get at or remove, but I was able to see this piece of print here where the positive side of the capacitor was. And when I bridged from this point to this point here, it sprang into life. So there was definitely a break in the print somewhere along this line here. And now I have both channels working. Happy days. And I'll never know whether this chip was really faulty in the first place. But hey, that's the way it goes. You may remember from part 1 of this video that one of the problems of this radio was that there was actually no FM reception whatsoever. And this was the next area that I wanted to address to try and sort out. And I was hoping it wasn't this chip here, because like the audio chip, it was going to be a nightmare to actually get and replace. So I started off doing a few tests with the voltmeter. Now I knew that the digital counter here was giving a readout when the FM band was selecting. So that was suggesting that the oscillator section of the FM band up here, a varicap diode oscillator, was working. But there was no signal getting through here. So on testing with the meter some of the voltages that are mentioned here, I started around here and everything seemed to be okay on the IF demodulator, the voltages at least. So I started to work back and got to this transistor here. This is one of the IF transistors, and it gets its collector voltage from this point down here, along here through these resistors up to here, and that was fine. But there should be a 2.7 volt reading on the emitter, and in this case there was only 0.1 of a volt, and again nothing on the base at all. So it struck me that this transistor was probably faulty. So I managed to get a replacement, a BF241, an IF transistor, and sure enough that cured the fault, and suddenly I now have beautifully clear, crystal clear FM reception coming through. And this is the little transistor in question, and I'm just going to put it into the component tester to see what it reads out, if anything. Here's the faulty transistor under test, and it registers as an NPN transistor, and it says the HFE, or the gain, is 76, and that sounds very low. So let's put in a good transistor and see what the difference is. I'm just spreading out the legs a little bit to fit into the socket. And here we are with the good transistor, and you can see the gain is much higher. 127 is against, what was it, 87 or something. So maybe that's what contributed to the faulty component. But anyway, we have crystal clear FM reception now. Fantastic. And here we are with the chassis still out of the cabinet, but the FM working beautifully. And I'll just show you what it sounds like through some of the presets that we have on the top here. There are 5 or 6 preset buttons for the FM channel.
Influences and magnificent obsessions that brought Ireland's formal gardens. Walsh, the largest nightclubs, has doubled up as a COVID vaccination centre this evening. The jabs after joining a British government campaign. It made sense for students. On a March morning in 1692, a 30-year-old Arthur...
And one of the other things I've done in the meantime is to replace the incandescent bulb which was gone in this little meter here. And instead of a bulb which I couldn't get my hands on anyway, I've put in a warm white LED here, along with a 680 ohm resistor in series to drop the current. And it works beautifully well. And it mimics very well the incandescent bulb that was in there before. So I'm happy with that. At this point, I think this video has gone on long enough, so I'm going to tail off here. And hopefully in the next section, I can get the chassis finished back into the cabinet and complete this restoration and repair. So if you have been, thanks for watching.